In section 11.4, we're going to focus on trapezoids and kites. So just a general trapezoid, remember we have one pair of parallel sides. It's the main thing about a trapezoid. Just to take a look here, those two parallel sides we call our bases, and the other two sides we call our legs. Specifically, an isosceles trapezoid has congruent legs. There's also some other information we can determine by these, which is that base angle pairs are congruent. So notice those bottom angles there. In green, I would call a base angle pair, and those top angles I would call another base angle pair. Those are congruent. And then the angles that are stacked on top of each other there are supplementary. Also, last thing there, diagonals in an isosceles trapezoid are congruent. So in an example problem here, we have an isosceles trapezoid. I'm given that angle C is 65 degrees, and I want to figure out what angle D, E, and F are. Angle D is stacked on top of angle C, so I know that they add up to 180. So to find angle D, I would do 180 minus 65, and I'd be left with 115. So I'll put that there. Angle E and angle D are base angle pairs. So if angle D is 115, E is also 115. Finally, F and C are another base angle pair. So if angle C is 65 degrees, then angle F is also 65 degrees. And now let's talk about kites. So kites, we already know consecutive sides are congruent. The only other really important fact about a kite is to know that diagonals are perpendicular. So let's go through a problem here. I'm given a kite here, and I want to figure out what angle 1, angle 2, and angle 3 are. Right out the gate, I know that angle 1 is 90 degrees because that angle is formed by the two diagonals, which we know in a kite, diagonals are perpendicular. Now, if I kind of look to find angle 2 here, I see that angle 2 is a part of this little triangle that I highlighted in pink. Using the triangle angle sum theorem, I know that all the angles in a triangle have to add up to 180. So if I add up angle 1, angle 2, and that 52 degrees, I'm left with really only angle 2 to find. So if I subtract 90 and 52 by 180, I'm left with 38 degrees, and that would have to be angle 2. Now finally, to find angle 3, this one's going to be a little bit weird. Notice here that triangle DFE would be congruent to triangle DGF by side, side, side. So remember, consecutive angles are congruent, and they also share that side length DF. So if those two triangles are congruent, then that would mean that angle 3 and that angle 52 would match up to each other and be congruent by CP/CTC. Therefore, angle 3 would also have to be 52 degrees. Finally, let's talk about some area formulas. Trapezoid, the area is 1/2 our bases added together times our vertical height. And for a kite, to find the area, I take both diagonals, I multiply them together and divide them by 2. We'll look at some example problems in class.